Module 1 homework. We're going to start by drawing constitutional isomers. Remember, constitutional isomers is where we take a chemical formula. So here we're going to take C2H6O and see how many different ways we can rearrange these atoms by using all of the atoms in the chemical formula. So I'm going to start by making a carbon-carbon bond, because why not? And then I'm going to put 3 hydrogens here. This one's going to want 2 hydrogens, so I must want 1 more hydrogen here. So I've used both carbons, I've used 6 hydrogens and 1 oxygen. So this would look, with the condensed structure, like this, and that is ethanol. So then how else can we arrange this? Well, I could put the oxygen between the carbons like this, and that is an ether, and that is called dimethyl ether. And I don't have another way that I can rearrange this and use all of my atoms. So these are the 2 isomers that I can draw from this chemical formula. Number 2. What is the name of the functional group in this structure? Now, you do need to be able to pick out any of the functional groups that were discussed in the lecture. And this one is an aldehyde. Now, it's possible that on your quiz question, you may have to type in this name rather than pick it from a drop-down. I'm trying to update the questions, but I can only work so fast. What is the molecular formula of an alkane that has 17 carbons? So we're looking for 17 carbon atoms. You need to remember the generic formula for an alkane. The generic formula is CnH2n plus 2. In this case, 17 is N. So we have C17, and then 2 times that is 34, plus 2 is 36. So it would be C17H6. Now, to enter it into this system, you would have a capital C. Just type the 17 directly after it, no spaces, H36. That's all you need to do. Now, what is the IUPAC name of this compound? Here we start with our parent chain, which is the cyclic compound in this structure. And we have 6 carbons. So it is a cyclohexane. Then we have to name our substituents. We have one of these here, and then here we have one of these. This is a methyl group. This is a sec-butyl group. See, it was butane, but then we took off one of those secondary hydrogens and it made it sec-butyl. So now how do we put these in order and how do we number this around? Well, remember, when we're putting it in order and we're numbering, we ignore the prefix. So we're looking at B and M. And all things being equal, the B is going to get the number 1. So this is going to be 1 sec-butyl 3 methyl cyclohexane. And you put that into this system like this. Now, do remember that I grade all assignments manually. So if you have just a space or you missed a dash, or you may have slightly misspelled a word, I will go through and I will correct it. So don't trust the server-generated grade. Question 5 is going to be the one that you're going to spend the most time on the quiz, and that's because it's worth 10 points on the quiz. Here on the homework, it's going to be worth 5 points. Now, this particular question is the hardest of them in the pool, and this question is in the pool, so if you get it, you've already solved it in the homework once. So we're going to start by taking this compound name 5-chloro-3-ethyl heptan-2-all. And we're going to draw the condensed formula, the Lewis or the Kekula formula, as well as the skeletal or shorthand formula. Now, it's my opinion that starting with the skeletal is the easiest. If you want to start with one of the other ones, go right ahead, knock yourself out. So I like to start with the skeletal formula because that's the easiest for me to see. And I can draw my zigzag so that I have 7 carbons. Remember, we have a carbon at every end and every bend. So this zigzag represents 7 carbons. So I've done the hept part. Now at carbon 2, I need an ol, so I need an alcohol. And at carbon 3, I need an ethyl group. And an ethyl group looks like that. So then carbon 4, carbon 5 has a chlorine. So this is my skeletal structure. Now, this is the skeletal structure. Now I'm going to add a few things in so that we can make the condensed formula a little bit easier. So this is a CH3. This is a CH. This is a CH. This is a CH2. This is a CH, here's another CH2, and here is a CH3. This is a CH2, and this is a CH3. Now, after I do that, writing the condensed formula becomes very easy, at least if you can walk down the parent chain. So we're going to start here, and we're going to walk this way. So we have CH3, then we have CH, and on that CH is an OH, and we show that it's hanging off of the parent chain, it's not part of the parent chain, by putting it in parentheses. So now I'm back to the parent chain, and I'm going to come down here, and I have another CH. Then hanging off of that, off of this parent chain, which I show by putting it in parentheses, I have an ethyl group, and that is CH2, CH3. And I close the parentheses to show that that's all that's hanging off there. I'm back up to the parent chain. I come up to the CH2. Then I come down, and I'm down here at CH. This CH has something hanging off the parent chain. It's a chlorine, so I put that in parentheses. Come up here, I have another CH. I'm sorry, a CH2. And then finally a CH3. So that is the condensed formula. And you're going to have to enter that here into the system. And when you do that, smush everything together, no spaces, use correct capitalization, just put the numbers directly after the atoms, put the parentheses in, whatever you need, but just smush it all together. Remember, I do grade all of these assignments manually. Now for the Lewis or the Kekula structure, you need to expand this skeletal structure out. So what you're going to do is put all of the atoms bonded on one another like this. So we have a CH, we have a C that has an H2, CH, so you get the idea. So this is the one that has all of the bonds. We have CH2, here's a CH with a Cl, H2, H3. Now, it does not matter which side of the parent chain you put the chlorine and the ethyl. You could hang them up at the top too. It doesn't matter to me. We're not going to worry about that right now. So we have the skeletal, the condensed, and the Lewis or the Kekula structure. So now let's count how many primary, secondary, tertiary, and quaternary carbons do we have? Well, let's see. If I use, primary, let's start primary. All of your CH3s are primary. So we have 3 primary. 3 primaries. All of your CH2s, let's change it to here, are going, well, not all of your CH2s. So this one, this one, this one. These are going to be your secondary carbons. So we have 3 of those. They are bonded to other carbons, and that's how we know that. Then we have our tertiary carbons. Now a tertiary oh, I missed one. This is a secondary carbon. See how it's a CH, but it's bonded to 2 other carbons. So I'm incorrect there. There are 4 secondary carbons. Now the tertiary carbon is going to be bonded to 3 other carbons. Let's make that blue. And we do have a tertiary carbon right here showing 3 carbon-carbon bonds. We have no quaternary. You know what? I missed another secondary carbon. I see him now. This is a secondary carbon. So we don't have 4, we have 5. So all of these, 3, 5, we have 9 carbons. How many carbons do we have showing? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have everybody accounted for. 3, 5, and 1. So to enter this into the system, you simply type the numbers. Don't spell it out, don't put spaces, simply type the numbers.